Hi, I get a couple of questions coming at me recently around Kerberos and how it works with Zscaler Private Access, so I thought it was important to give you a bit of a run through on this. So Kerberos kind of fundamentally starts with DNS, especially in a Windows and Mac environment, meaning that a DNS server record, an SRV record, is used to discover the Kerberos ticketing servers, which are my Active Directory domain controllers, and then after that TCP and UDP port 88 to go off and get the Kerberos tickets. So I need to have a wildcard that matches my domain. I've got wellsgeek.net here, and it's going to auto-discover across a server group, which is my data center server group, and data center server group is going to use my data center connector. So it's essentially all I need for the DNS to function, and then I need the TCP and UDP port 88s to be able to pass through as an application segment. Really all I need for Kerberos to function. So from a couple of first principles, what I'll do here, I'll come across to a command line and I'll just show you here. I've got no Kerberos tickets, and if I run a KInit, it's going to fail. And the reason it's going to fail is, Zscaler Private Access isn't running. I'm not able to get anywhere. And what you actually see here is it tried to find a KDC in wellsgeek.net and it got nothing. And the reason is, if I look at my kerb5.conf file, it says DNS lookup for my realm wellsgeek.net. And so essentially what that's going to do is, if we do a dig SRV underscore Kerberos underscore tcp.wellsgeek.net, it's going to go to my public DNS and try and find that. So now if I could also run that in a different way. If I do DNS SD -C for underscore Kerberos underscore TCP wellsgeek.net SRV record, it's going to do the same thing. It's going to go into such record. And the reason why I'm demonstrating DNS SD is it behaves slightly differently at an operating system level in relation to how Zscaler Private Access or Zscaler App does the DNS interception. So this is why it's failing when I'm off network. Obviously I'm also off network, so all the Kerberos processes that I should be accessing are not accessible, but I thought it's important to show you how that works when it's in a failure state. So let's go ahead and open up Zscaler App, and I'll sign in here, wellsgeek.net, and I'm going to use our Zscaler 2 cloud to sign in. So give this a second. I'm on a personal hotspot, so it's a little bit slow, but it's important to demonstrate the being off network. Using certificate-based authentication to enroll in Zscaler App to differentiate the different authentication mechanisms that are in play. So now let's go ahead and look at this. Zscaler App is just making its connectivity. It's connected to the broker. Zscaler Internet Access is connected. I'm using the DTLS tunnel, the 2.0 version, to capture all ports and all protocols at a Zscaler Internet Access perspective. So let's minimize that. Now go back to my Kerberos. I haven't got my Kerberos tickets. If I run that DNS SD, you can see now that what's actually happened is it resolves Kerberos TCP wellsgeek.net, and it's given me the domain controller dc2 wellsgeek.net, priority 100, and it's running on TCP port 88. Now if I look at my logs, what I can do is I can tail this log, and if I grep for inf.star.srv and I rerun that command, we should start to see these logs coming through. in actual fact, because it's already cached in, I'd have to wait for a TTL to occur. But let's go back through the last 1,000 log lines, and I should be able to see that there. So this is what actually happened. We saw the DNS request come in. We sent underscore Kerberos underscore TCP to the broker, and the broker was able to resolve that via Zscaler and get the response back. So this is exactly what we want to happen. So if I now run a kinit, I can now get my Kerberos ticket granting ticket. And of course, to run through what exactly happened there, the DNS request went through, we discovered the domain controller, we then went through and did the TCP port 88 connection, negotiated with the password that I provided, and now I've got my ticket granting ticket. So if I have a look in diagnostics over here, here is the request that we saw. TCP port 88 from my user, here's my IP address. Went through the connector, and I transferred a bunch of data and was able to negotiate my Kerberos ticket granting ticket. So let's have a think about a couple of other things. So if I've got my Kerberos ticket now. If I can run a curl to HTTP, I know something, dc2.wellsgeek.net, cert serve -b, I get a denied message, and I get denied because it's 401 unauthorized and it's negotiate. So if I run that command again, -- negotiate -u : means use the current user. I could go off and get that file, and you can see here the negotiate blob was sent. What also happened in the background there was I went to the domain controller again. DNS lookup occurred, or some caching occurred, so I understand where my ticket granting, my KDC is that's going to grant me a ticket is, and I sent it my ticket granting ticket, and now I've got my service ticket, and you can see the time to live for each of those tokens there. So if we come back in here and we refresh these logs, all things being equal with regards to the logs being in sync, we seem to be a bit delayed on the logs, but we should start to see those logs coming through. We know that we did a TCP 88. We also know that we did a port 80 request as well. So there should be some logs that flow through into this relatively soon. So that's all working. Obviously, if we do it in a browser as well, we'd expect those tickets to come through. So let's go back from first principles. We'll destroy all those tickets. We'll kinit. I get my ticket granting ticket. So if I come in here and go HTTP DC2 cert serve, you get that transparent authentication, and that is because Kerberos happened in the background. So all well and good. The same is also true for other services. If we go and map a network drive, we'll connect to a server. I'm going to connect to my that same server, dc2wellsgeek.net, on my $C share. It's a CIFS connection, and that's now connected. You don't necessarily need to see all those files that are coming up, but you can see I also went off and got a Kerberos ticket for that CIFS connection as well, and that was what wasn't used to negotiate it. So all well and good. I've demonstrated it to on a Mac. Macs are, of course, becoming increasingly more popular, but really, I suppose that the use case that most people are going to see is going to be on Windows. So what I'm going to do here is I'm going to log out of Zscaler App, and I'm going to start up my my Windows 10 virtual machine to show you the same thing happening there. Okay, so Windows 10 is launched. We'll go to Zscaler App, open Zscaler, and we'll sign in again in the same way. So certificate-based authentication, I should automate that so it automatically sends my default certificate, but we'll go through that. So it registers Zscaler Internet Access and Zscaler Private Access, and away we go. So we're connected again, zTunnel 2.0, DTLS, and Zscaler Private Access is connected. So all well and good. So if we come in here and we'll run it, we'll go back to the command prompt because I think it demonstrates things. I've got all my tickets here. What we'll do is we'll go klist purge, slightly different language on Mac, on Windows. Tells me I'm going through Zscaler, and so again, if I go to http dc2.welshgeek.net/certserv, which is the page which is protected by Kerberos. Let's just do our NS lookup. Set type equals SRV underscore Kerberos underscore TCP welshgeek.net. So we got the response back 164.1.1. We'll issue that same curl with a V, and you can see that it's sending the Kerberos ticket at this point, and I got my I should have got my ticket there as expected. Kerberos, as you can see, works perfectly fine in both Windows and Mac through Zscaler Private Access. It's obviously dependent upon that discovery, the DNS functionality, and then once it's discovered, then those applications, the ticket, the Kerberos ticketing server, the KDC, passing through Zscaler Private Access. Hope that's useful. Appreciate the comments, or email me mark@zscaler.com. Thank you.